Good afternoon, class. Today we're going to begin our discussion of logarithms, and hopefully you'll remember some of the stuff we were doing with exponents the last time. Last time we defined exponential functions, looked at rules of exponents, like this x to the m over n. If the top exponent is, or top number, is something other than 1, then that's the power. The bottom number is the root. Like 256 to the 3/4 power. You take the 4th root and then cube it. So the stuff we were doing the last time has a lot to do with logarithms. And like the last time we said, okay, for an exponential function, we always assume the base is a positive number, but not 1. All of that's going to still be significant today. In fact, before I define logarithm, let's just go ahead and make a statement that when we use the variable b, it's a positive number, but not the number 1. Okay? And start off by defining logarithm. Log base b, this is a subscript of x. Log base b of x equals y means b to the y power is x. A logarithm is just a fancy way of expressing an exponent. A logarithm is just a fancy way of expressing an exponent, and so those properties of exponents that we have, we can rewrite them in terms of logarithms. And notice something. The base b, the base of the logarithm, is the base of the exponent. When you rewrite it as an exponent, the base of the logarithm becomes the base of the exponent. B to the y power is equal to x. And if you understand what we're saying there, then I think we could you could evaluate some logarithms. Let's see. Using what you know about exponents.
And the multiplication tables. Log base 5 of 25 equals blank.
5 to what power gives you 25? 5 squared. So 5 to the second power.
5 squared is 25. So log base 5 of 25 is 2.
5 to the second power equals 25.
It's just another way of writing this. 5 squared equals 25. Here's another way you could write it. Log base 5 of 25 equals 2. That's the same thing as saying 5 squared is 25. Notice when you're writing logarithms, the base is written small. It's a subscript. When you write it with exponents, the base is written normal size. With logarithms, the exponent is written normal size. When you write it as an exponential statement, the exponent is the thing that's written small. It's a superscript.
What about log base 3 of 1?
Yeah, that's a good one. Okay, here's another one. Log base 3 of 1. This is tricky.
You're going to have to remember one of those properties of exponents.
Here's what I'm thinking. What exponent do I put on 3 in order to get 1? 0. 3 to the 0 power is 1. That was that first rule we stated the last time, wasn't it? On April 5th. Anything to the 0 power is defined to be 1. Well, except for 0 to the 0.
0 to the 0 is undefined.
Discuss that. Okay. Now, I guess if you want to state a rule of logarithms, here's a rule. Log base b. It doesn't matter what that base is. Like on this problem right here, log base b of 1. It's not, 3 isn't significant. If that 3 had been a 10, the answer would still be 0. anything to the 0 power has to be 1. So here's my purple rule. Log base b of 1 equals 0. It doesn't matter what the base is. Now, I want to mention some notation because it's going to pop up eventually in the assignment. Sometimes it pops up in the first 2 or 3 problems. Other times it's not until we're halfway through with the assignment before you finally see it popping up. If you see just log written and there's not the little base there, assume it's base 10. So if you want log base 10, you don't have to write that little subscript.
If your calculator has an log key on it and no subscript, that is a log base 10. Log base 10 is called the common logarithm.
Mm-hmm.
Because before calculators, that was pretty much the only logarithm they used in books, because it's easy to take 10 to a power, but
on this one, log,
that's a log
base 10. Now there's another logarithm key. It's right underneath that log. It's sort of hard to see. It's written capital LN, but we won't write it capital because in my math lab you're going to be typing this stuff in. Never type a capital letter and never hit a space key. So this is read LN, or you could call it the natural log, and it's log base. Do you all remember that lowercase letter e that we used last time? It's a decimal number, 2.718281828.924, I think it is. And it keeps going and going and going. The log, that's called the common log. Ln is read natural log.
The natural logarithm is actually much more common now than the common logarithm. Years ago, I ran into someone that we knew going through graduate school who worked for was a computer programmer for TI, and I asked him, they're standing around at these conferences trying to find something to talk about, and so I asked the question, tell me, why is natural logarithm more common than the common logarithm now? And his response was smaller base, 2.7 smaller than 10. And I was like, oh, okay. To him, it seems, it was relevant. To me, it didn't matter, but
okay.
Common logarithm is not as common as it used to be.
Yeah. But anyway, now I'm going to state a couple of rules called the common base rules of logarithm. And here it is. Log base b, that's a subscript right here, of b to the, any letter you want. I guess I'll use x.
Y'all can help me figure this out.
It's sort of like who's buried in Lincoln's tomb or Grant's tomb. Okay?
B to what power gives you b to the x? It should be obvious. What exponent do you put on this thing to get b to the x? X, right.
Did y'all hear that? B to the x is b to the x. The important thing when you look at that, it's saying if you have the same small base and large base, those cancel each other out.
It's canceling stuff out. God, that sounds familiar. I remember a few sections back. If you did the two things consecutively, they'd cancel themselves out and end up where they started.
Like the fog x would equal x and the golf x
would equal x. Maybe those are inverse functions. That's what's happening here. We're performing the two functions consecutively in either order, and they cancel each other out. And it doesn't matter the order in which you write it.
If you have it written like this, b And then in the exponent, log base b of x, as long as you have the same small base and big base, as long
And
as
they're
those are
performed
the same number.
consecutively, they cancel each other out, leaving you just x.
Is that up high enough? So those are the common base rules of logarithms, and that's what we're going to start using with problem number 1. So as you go through this, try not to panic too much. Traditionally, students do very, very well on this logarithm stuff. So let me write down problem 1. It says, solve the logarithmic equation. Oh, wow, we have new equations to solve, Tim.
Oh, wait a minute. I don't like this. Don't write that down.
Oh, yeah, you're going to have the same number appearing.
This is better.
Okay.
Well, not really. But
Now,
in a way, yeah.
x, when it says solve an equation, that means you want to get it in the form x equals some number, right? Log base 5 of 1 over 625. Log x equals log base 5 of 1 over 625. Here's how I've sort of color-coded it. Oh, that 5 is a subscript. It doesn't look it, does it? It looks like it's the same size as that G. But pretend it's a subscript. When it says solve an equation, we want x equals some number. So we need to somehow cancel out this log base 5. We just want x equals a number. It could be positive, it can be negative, it can be a fraction, but we don't want this log base 5. So here's my thought process.
We want to cancel out a log base 5. Look up here. How you canceled that log base 5. If we could get a 5 to a power there.
If I can write it with a big 5 right here. Okay, let's see. How many 5s do we need to multiply together to get 625?
I was thinking 5 to the 4th.
Let's start multiplying out. 5.
Is it 5 to the 4th? 5 to the 4th is 625.
Okay.
But remember, it's 1 over. So what do you do to that exponent when you want a 1 over?
Yes,
Negative.
that
Good.
was stuff from
Look
the last
back.
time. Let's look back. Do some problems like
Go back.
1 over 7 to the 5th. To write it, the instructions for that problem said write this without a fraction, and you would write it as 7 to the negative 5. A negative exponent means 1 over. So going in reverse, to get rid of a 1 over, make the exponent negative. Okay? I think I said the last time you could actually say that if you want to say something mathematical. To get rid of a 1 over, make the exponent negative. So, now that I have it written like this, you'll see where I'm getting the 5 to the negative 4. 5 to the 4th is 625. I made it negative to get rid of that 1 over. And now, we have the same small base and big base. So all of this cancels out using this rule right here. And we have x on the left equals what? Negative 4. So when you're solving an equation, you always want that x equals a number. So we had to cancel out that log base 5.
I hope we're not going to get logged out.
Oh,
Let's see. Negative 4.
Okay. Let's see number 2.
Oh, y'all remember my bag of tricks. I said what to do. If we run into a radical with exponentials or logarithms, there was some trick we would do.
Log base 6 of, oh, is that a cube root of 36? Well, We just want x equals a number like this over here on problem 1. We don't want that log base 6. So, in order for these to cancel out,
what do you need to have as the base right here to cancel out that log base 6? You need a 6.
now, this goes back to something that we said the last time. Probably going to get sick of me referring. Remember, if you have an m over n power, the top number is the power, the bottom number is the root. So how am I going to rewrite this? 6 squared is 36, all over what? What number goes in the bottom here? 3. The top number is the power, 6 squared is 36, the bottom number is the root.
And you would cancel it out so you get 2 thirds?
Now they can cancel out all those logarithms and that logarithm and the 2 6's. We cancel those out, leaving just x equals 2 thirds.
You say, well, suppose that weren't a 36. Suppose it were a 35.
Then,
Well, this method doesn't always work. Sometimes
for their homework,
for
it'll
your
work.
homework, it's going to work because if you can't get a common base the way we're doing here, then this method just can't be applied. And we have something called the change of base formula that we can use and just evaluate using a calculator, but it would be a non-terminating, non-repeating decimal. It would be an irrational number. If you're going to get an exact solution, you're going to need the problem set up so you can get a common base.
And those common bases occur much more than you would think. Okay. I'm now flipping to I'm going to do number 3, but you got to show it.
Okay.
Right. Number 3. What is that, log?
No.
Oh, wait.
X
What am I?
equals 3 to the log base 3 of 13.
That purple wasn't good. X equals 3 raised to the log base 3 of 13. This problem is either easy or downright impossible. Okay, one or the other. The direct application of this second common base rule. I think we have a 3 log base 3, 13. If you have the same big number and small number, all of that cancels, leaving just x equals 13.
Exponential and logarithmic functions are inverses. If they're performed consecutively in either order, they cancel each other out, leaving you whatever you started with there.
And again, the natural question is, well, what happens if this had been a 3 and that had been a 4? Well, realistically, that doesn't happen.
You're going to see that what we're going to be doing is when we start solving messier equations, you'll be deciding on for yourself.
I think the very next problem is going to illustrate that.
You're going to decide for yourself, what number do I put here to cancel out that log base 3?
Well,
and so,
punch in 13 so they'll see that it's right.
Oh, my finger is much better. If you're wondering, it's much better. I just removed tape before I came to class, and I was scratching.
Oh, don't panic when you see that.
I don't think that's right.
I know.
Oh, here it is. Oh.
Okay, it says solve the given logarithmic equation, log base 2 of x equals 3. Well, it's still saying solve an equation, so we want our answer to be x equals some number. So we need to isolate this x. In the first 3, the x was already isolated. Y'all agree? First 3 problems. Oops.
I gotta switch over.
In the first 3, the x was already by itself. 1, 2, 3. Here the x isn't by itself. We need to get that x by itself. So we need to somehow get rid of this log base 2.
Well, let's turn everything that's written there into exponents. What base could we put here to cancel out that log base 2? Now realize if you're putting the base 2, a base here, you're going to have to put it over there also.
Yeah, if I put a big base of 2 right here, that'll cancel that out. But I got to put the big 2 over here. At this point, the black stuff became exponents. But this isn't a 23, it's a 2 cubed. Now, why did I put a 2 there? Because that's the number that was right here. I'm choosing which number to put on both sides. Whatever this base is, if the base had been a 5, I would have put a 5. So there's really no logical times when you're going to have, say right here at number 3, there's no logical time when you would have a base 5 there, but a log base 3 there. Because you're choosing the number to put there to cancel out the logarithm. And the base that you use is the base of the logarithm. So these... Yeah, 2 cubed, don't say 6. What's 2 times 2 times 2? 8. Okay?
Wait, oh, you were still writing one.
Oh. Now see how I did that? Whatever the base is, that's what, of the logarithm, that's what you put on both sides. Why did I do that here and not on the other ones? On the other ones, the x was already isolated. Here, I had to somehow get rid of that log base 2. I wanted the x by itself, so I just have x equals a number. Any questions on that? Should we do a similar problem?
Oh, and I should mention, hey, why can we do this? What enables us to do this? Remember when we were solving exponential equations the last time? We said the same base method, if b to the x equals b to the y, then x equals y.
Yeah.
If the bases are equal, the powers have to be equal. Now we're just going backwards. The powers are equal, put on the same base. That's why we're able to put that base 2 on both sides. We're just using the same base method that we used to solve exponential equations in reverse. Now
let's do another number 4. So similar question. Log. For a moment I was going to say it's the same problem, but no it isn't. Log base 3 of x equals 2. We need that x by itself, which means we have to get rid of that log base 3. So what big number am I going to put right here that'll cancel that? 3. Okay. Oh, we can't see it, Tim.
You're right.
I'm sorry about that. What big number do I have to put right here to cancel out this? Well, a 3. So I've got to put the 3 over here too. Did y'all hear that? When these cancel, we have x on the left, and this is a 3 squared. Let me try to write it a little neater so it's more obvious that 2 is an exponent. 3.
To write it as a fraction.
You want to write it what, a 1 over 9 or something, or?
3 over 3.
It does sort of look. If I had a fraction bar there, it'd look like a fraction would have.
Well, you sort of do have a bar there.
Confusing myself.
But this little 2 is a fraction now. When you put the big base on each side, everything else becomes not a fraction, an exponent. The 2 is an exponent, not a fraction. I'm saying what you're saying. Right?
You know, I'm going to have to do this. I'm going to make that new teacher mistake, okay? Because this is one of those things that Tony and I do differently.
Because I'm only going to do it the way we're doing it tomorrow on Wednesday.
Well, still.
Okay.
Something.
He's going to do it a different way.
Don't write this down, okay?
We're doing it on Wednesday.
Don't write this down, but still. There's the problem. Remember the definition of logarithm. Base to the power on the other side
is equal to, the thing that follows the log notation is called the argument. Base to the power on the other side equals the argument. So here we go. Base, convert it to exponents using that definition. Base 3 to the power on the other side 2 is equal to x. Base to the power equals the argument. We got x by itself. 3 squared is equal to 9. So if you view an example, you might see it done like that. But the stuff that we'll be doing on Wednesday requires this idea of whatever the base is on the logarithm, that's what you use as the base of the exponent to cancel that log notation out. Okay. Now there are 3 rules of logarithms, which are called names.
The next page. I'm at the top of the next page.
Okay. So they're all right there. Okay. I'm going to write these 3 rules. The first rule is called the product rule. This is the product rule of logarithms. Log. I'm deliberately making my L cursive because it's an L, not a capital I. When you're typing logarithms, every log notation starts with an L, not an I. That LN, that natural logarithm, you have no idea how many emails we will get from students sending screenshots showing them typing in the capital I-N. And they're counting it wrong. And logarithm doesn't start with an I. It starts with an L. Plus, from day one, I said, never, ever enter a capital letter on Pearson MyLab. If you can't enter a capital letter, then it can't be a capital I. It's got to be a lowercase l. But here's the product rule. Log base b of m times n. Product means multiplication. Is log base b of m plus log base b of n. So we can rewrite the log of a product as the sum of 2 logarithms. And there's something I want to remind y'all of, okay? It's called the product rule of exponents. The product rule of exponents looks like this. I'm going to write it right here. Let's say b to the m times b to the n. If you have repeated bases being multiplied, like x times x. X times x. Say you have an x squared and an x to the 7th or something. If you have repeated bases being multiplied, you can rewrite it as a single power b by adding the exponents, m plus n. Remember I said that a logarithm is just a fancy way of expressing an exponent. So there's sort of a strange similarity between the product rule of exponents and the product rule of logarithms. The product rule of exponents says if the bases are repeated, you add the exponents, you add the powers. The product rule of logarithms says if the arguments are being multiplied, you add the individual logarithms. The bases are being multiplied, add the powers. Arguments being multiplied, add the logarithms. No, they're 2 separate things completely. We have the log base b of m and the log base b of n, and you don't change the b's, you don't change the m and n. And you'll see examples. Once we get to examples, it'll make more sense.
It's just writing it out the long way.
You can take the log of a product and write it as a sum of individual logarithms so that the step inside here isn't so messy. Hey, before we state the quotient rule of logarithms,
I'm going to remind y'all of the quotient rule of exponents because I bet y'all can figure out what Tony's going to write here. Here's the quotient rule of exponents. It says b to the m divided by b to the n. If we have the same base being divided above and below, what can we do? This is the cancellation property. What do we do to those exponents? When the bases are multiplied, you add the powers, you subtract. This is the cancellation property. It's also called the quotient rule of exponents. You subtract. Same base being divided, you subtract the powers. So I bet y'all can figure out what you're going to do to the logarithms over there. If you multiply, if the product rule says you rewrite multiplication as addition, most students will say you're going to rewrite division as subtraction. Correct. So it's log base b of m minus log base b of n. And one more of these properties called the power rule. At first glance, this power rule of logarithms looks sort of crazy, but once he states it, then I'm going to remind you of the power rule of exponents, which we used the last time to justify this. I was to m to the n. Log base b of m to the n. If you have an exponent here at the end of the logarithm, you can move that exponent down in front and write it as n times log base b of m. The exponent becomes the coefficient on the logarithm. That's if you have the exponent at the end of the logarithm. That exponent has to apply to the entire argument. Now, we're going to... Well, first of all, let me remind y'all of the power rule of exponents. Y'all used it the last time. The power rule of exponents. The power rule of exponents, I don't remember what letters were used. Do you have another pen? I'll use below. The power rule of exponents says b to the m, all raised to the n power. A power raised to a power. What do we do to the m and n? I remember that from back. You multiply b to the m times n. A power raised to a power, you multiply. Now remember, I said a logarithm is just a fancy way of expressing an exponent. So we have an exponent to a power. Well, an exponent is another way of saying a power. So we just have a power raised to a power. You multiply. You multiply that power by log base m, b of m, the other power. Power raised to a power, you're multiplying the two. It's just a restatement, a bizarre restatement of the power rule of exponents. Now, we're going to start doing something called expanding logarithms. And Tim, why don't you show them example 5? It's a multiple choice thing. And you're going to panic at first. I'm not going to panic. I can promise you.
Okay. They will panic when they see it. But trust me, in a little while you'll be able to do this in your head. Okay?
Your goal is to be able to do this. It says use properties of logarithms to rewrite the expression, simplify as much as possible. This is called expanding, when you have one logarithm and you're going to write it as multiple logarithms.
Yes, like here we had started off with one logarithm, they're rewriting it with 4 logarithms, 4 smaller logarithms. That's what it means when it says rewrite the expression.
Rather than this whole huge argument there, I want a small.
Eventually the instructions will start saying expand.
Maybe you should write that out, define it. Expand a logarithm, colon, write one logarithm as multiple logarithms. Let me switch over.
Expand a logarithm means write one large logarithm. By that I mean there's a whole lot of stuff in the logarithm as a
Sum
or difference of smaller logarithms.
Okay.
And there's a order in which you go to, if you're going, that you follow to expand a logarithm. What I'm going to do one example showing all of the steps. At that point, we're going to see if you can do it in a lot fewer steps. Okay? Sometimes students say, oh, I don't like my teacher, he doesn't show the steps and all of this. This is one of those things where it's easier not to show a lot of steps. So, we're going to go in this order. To expand a logarithm, showing all the steps, you first use, the quotient rule.
So,
four-step process.
In order to use the quotient rule, your argument has to have a fraction bar. Okay?
Then, we'll use the product rule. Now the third step, I'm going to leave that blank and see if y'all can figure it out when we get to it.
There's only one other rule that you haven't mentioned.
No, the fourth rule is the power rule.
Oh, I see what you mean. Okay.
There's
maybe some.
Okay.
I'll give you a hint. It starts with a D.
Oh, Tim.
Number 3.
I've never had to give them hints in the past.
Okay. Well, let's see.
Okay. We're going to expand this logarithm, and we're going to show all the steps. Log base 7 of x squared y to the 1/3 over a cubed c to the 4th. Well, first thing we're going to do is the quotient rule. The quotient rule says you go log top minus log bottom. So I'm going to put I'm going to make the fraction bar red here. And I'm using the quotient rule, writing it as log base 7 of x squared y to the 1/3 minus log base 7 a to the 3rd c to the 4th. That's the quotient rule. It says go log top minus log bottom. And that's what I did. So I'll make a note. QR for quotient rule. Oh, no, okay.
Now I think we have a product. Look at this first logarithm. We have x squared times y to the 1/3.
I'm going to put little dots to indicate the products, which means we're going to actually use the product rule how many times?
We're going to have to use it on this first logarithm and the second one as well. Okay.
So this is product rule. I'm going to have to write sort of small. I'm using the product rule right here. It's log base 7 of x squared plus log base 7 of y to the 1/3. Notice how the log, we're getting more and more logarithms, but each logarithm is smaller. By that I mean there's not so much stuff after it.
The argument is simpler. At this point we only have one variable in each one of those arguments. And what I like to do, it's an unnecessary set of parentheses. What I'm doing is unnecessary, but I like to enclose, okay, those parentheses there. The stuff in those parentheses came from that first logarithm. Now the step in the next parentheses, that's going to come from the second logarithm.
So it would be log base 7 of a to the third plus log base 7 of c to the fourth. So I use the product rule twice. Rewrite the multiplication as addition. Go ahead.
The first logarithm, we wrote the multiplication as addition. The second logarithm, we wrote the multiplication as addition.
So we've used the quotient rule. We've used the product rule. Now, brother's written the parentheses there, which give the hint of this third step.
The first set of parentheses that I wrote, and it was an unnecessary set. There's nothing there in front to distribute. We can just drop those parentheses right there. But the second set, that is not an unnecessary set. You have that minus in front. When you have parentheses with a minus in front, you're going to have to distribute. There, that's that third step that Tony referred to. That
distribute the minus. Okay, distribute the minus. So I'm now writing it log base 7 of x squared plus log base 7 of y to the 1/3, then a minus log base 7 of a cubed, and a minus log base 7 of c to the 4th. So what I just did there was distribute the minus. That was that third step. One last step. We're rewriting this really messy looking logarithm as sum and difference of small logarithms. The last step is the power rule. And what does that power rule say? If you have an exponent at the end of the logarithm, you move it in front. So starting with this first logarithm, this is now power rule. There's an exponent at the end, so I move it in front of the letter L. So it's 2 log base 7 of x plus, is there an exponent at the end here? Yes, so you move it in front of the letter L. You still have the minus. There's an exponent at the end of the third logarithm. It goes in front of the letter L. And what's the last thing I'm going to do? I move the 4. Log base 7 of c. So there. That's the answer. The natural question to ask is, can you do it without showing all those steps? The answer is yes. Then the next question is, how do you go about writing it without expanding it without all those steps? Well, the phrase that you're going to hear me say is you separate logarithms at multiplication and division. So I'm going to try to figure out, how do I get this answer without all of that?
You want to go, this one in particular, you should be able to go from the problem he wrote directly to the final answer. Okay, let's see. The final answer had how many total logarithms? 4 total logarithms. Remember, you separate at multiplication and division.
Someone says, say something about logarithms. You can say, separate logarithms at multiplication and division. You could even be more specific and say, do not separate logarithms at addition or subtraction.
We'll write that as a rule in a little bit. For the time being, we have 2 distinct factors on top, x and y. So we know we're going to need 2 logarithms there. How many distinct factors do we have on the bottom? 2. So that's a total of 4 logarithms. 4 logarithms. Now, hey, here's something interesting. The first 2 logarithms, I don't see a sign there in front of that 2, so we assume it's what?
Positive.
Positive, okay. So the first 2 are positive or preceded by positives. The last 2 are preceded by negatives. How do we know which ones have positives in front? And more importantly, how do we know which logarithms are going to have minuses in front?
Did y'all hear that? The stuff on top has a plus in front of it. The stuff on the bottom has a minus in front of it.
If you're splitting it up, when you split it up, showing all the steps, that a cubed and c to the 4th, those logarithms have a minus in front. You'll have to distribute. So the factors,
You don't even have to write anything down.
you should be able to go from this
here
here,
to there, without showing any of the work.
and that's
Okay,
what
I
we're
think
gonna
you're
be
getting,
doing.
Jennifer.
It's
Said
2
it's
log x,
And then where did the coefficients come from?
the exponent.
the 1/3
The exponents,
y.
okay.
I'm going to write a really messy example, and we're going to try to expand it.
And then it goes
Right
to
now.
the bottom, and then there's the negatives. I got it.
And it's-
Okay, you got
Okay,
the
wait a
pattern.
minute.
You see
Wait
it?
a minute.
Oh.
Let's do this one before we get timed out, okay?
Oh, okay. Well, why don't you just click the wrong answer?
Oh, you're right, okay.
Click on it.
Okay, I'm
Yeah,
going to
wait.
click a wrong answer just to keep us going, okay?
Oh, okay.
Okay, don't write it down yet. Tony has one he wants to do on his own.
Just to make sure y'all see the pattern. Suppose we want to expand log base 3 of x to the 5th,
Do one with the right.
y to the 3rd, you want to do that? Okay, I was going to wait to do that. Square root of w
Oh, now you just messed it up.
all over 3a to the 1/2.
Realize this 3 is the exponent on the y. It's not saying a cube root. I guess I
you
should
see, I
have-
think I should have just not done that one. But okay, we're going to have to rewrite this one first. If you have a radical, write it with a fractional exponent. And so this square root, what fractional exponent am I going to write it as? A 1/2. Okay? Remember, the square root is the same thing as a 1/2 power. So here's the thing I'm going to try to expand. X to the 5th, y to the 3rd, w to the 1/2. Y'all remember that from the last time. And then we have a 3 and an a to the 1/2. Look what I meant. Do y'all remember that from the last time? How do you take a square root and write it like, okay, here we had 23 to the 1/2. You wrote it at, the square root of 23, you had to write it as 23 to the 1/2. On problem 12, it was cube root of 22. How do you write it without that cube root? Okay. You go 1/3. Do y'all remember that? That's what I did right here, rewriting the square root of w as a w to the 1/2.
How many distinct factors do we have on top?
3.
3. X times y times w. Now be careful. On the bottom, how many distinct factors do we have? 3 times a to the 1/2. I think I heard it.
Negative.
Okay. There are 2 distinct factors on the bottom. 3 times the a.
I remember once a student told me, you seem to think those red dots and that red line you're drawing is important, and I don't get why you seem to think that's important. And I was like, yes, it's important. That's how you separate it. You separate it multiplication and division. That's what I'm showing. Everywhere there's multiplication, and then there's only one place there's division. It's that fraction bar. So this is going to separate into 1, 2, 3, 4, 5 logarithms to get started. And now I'm just writing out the answer. The exponent goes in front of the letter L. So call it out, Jennifer. 5
log 3
of x. I remember years ago a student saying, oh my gosh, it takes so much longer to type these answers in than it does to do the problem. And I was like, yeah. Okay.
Then plus.
Okay, plus, because we're still on top.
3 log 3.
Okay, 3 log base 3 of y,
Plus 1/2. Log 3 w. Minus 3 log.
You know what? Could I do something?
No. What did I do?
But no, you didn't do anything. It'll be a better example if this 3 were an 8. So this 3 in the bottom, I'm changing to an 8.
Change it to
Too many 3s. Okay, this is an 8 right there.
Now let me ask you something. Is there an exponent on that 8?
No.
So there's not going to be a coefficient in front of it. It's just log base 3 of 8. Now what's the next sign? Plus or minus?
Plus.
Minus, because the a is now in the denominator. Once you switch to a minus, you can't go back to a plus. Because everything else is in the denominator, so it's preceded by a minus.
Okay, so if the number is by itself, it's only going to be...
Notice sometimes students think put the number in front of the letter L. No. There's not an exponent.
Minus log 3 6 or minus log 3 5.
Okay. There's not a exponent on it. If it's just a plain number, you don't put that in front of the letter L.
No coefficient.
There's no exponent there to move in front. Okay.
Any questions here?
You'll sort of see the pattern. Separate at multiplication and division. That's the purpose of the red dots and the red line. The stuff on top has pluses in front of it. The exponents go in front of the letter L. The stuff on the bottom has minuses in front of it. The exponents still go in front of the letter L.
Okay, so let's do
that, number 5.
Now these things should start going faster. The longest part is going to be, there's only 1 or 2 that are multiple choice. We're going to have to be typing in most of these things.
So square root of x
times the cube root of y
times the cube root of y over
w to the 5th and a square root of z.
So there is a step you got to do before you can start just expanding. Get rid of those radical signs.
Look at this. I made it too big. Look at this right here. Notice that if you're looking at a cube root, that little index has to be right above the hook there on the radical. That's how you know that's a cube root. Is this 5? Is this 5 right over that hook? No. So that's not a 5th root. It's not a w times a 5th root. It's a w to the 5th and then a square root. Okay, so notice that little 3 to be a cube root, it has to be right there over the hook.
So for the y it'd be 1 over 3. But for the x it is 1/2, 1 over 2.
The z.
And the z, what exponent am I going to write? It's just a square root, so another 1/2. There's no getting around. You've got to be able to take those radicals and write them with the fractional exponents.
And I remember telling y'all, add that to your bag of tricks for exponentials or logarithmics. If you run into a problem with the radicals, you're going to have to rewrite them using fractional exponents. How many distinct factors do we have on top? On bottom? So how many logarithms are we going to have in our expansion? 4 logarithms.
How many
All right.
minus signs? Okay, so I'm just writing down the answer now. 1/2, the exponent goes in front of the letter L, log base 2 of x, then
Plus or minus?
plus
Because you're still on top.
1/3 log base 2 of y,
Plus or minus? Minus, because we're moving to the denominator.
and
And
you
it
can't go back to plus.
Because you've already done everything on top. You're not moving back to the top. So what's the next sign? Another minus.
Oh, 2z.
Mm-hmm.
Oh, maybe these answers are too long to be circling. This was the multiple choice one. You better get over there and check it before. We'll come back to this screen in a moment.
One. Okay.
Let's see, which one is it?
I think it's C. Okay. And let me come back over here. Return to this writing. There. Okay. When you get to number 6, notice it says there's an instructor tip as soon as you get to number 6. Never type capital letters or hit the space key. If you're typing it incorrectly, each logarithm will automatically bold. Logarithms always begin with a lowercase letter L, not a capital I. People will send us those screenshots. They've typed it correctly and it's counting wrong.
They know it's right. And I'm like, first of all, why would you think a logarithm starts with an I? That means, number one, you didn't watch the video. You hear me say over and over. So
the word logarithm begins with the letter L, not I. So here goes.
Wait, before we do another one, I want to make a statement. Separate logarithms at multiplication and division, not at addition or subtraction. If you look at number 5 on the multiple choice, the option D was cannot be simplified. Okay, going back to number 5, there was an option D, cannot be simplified. Suppose we had this, log base 3 of x squared plus y cubed minus z to the 5th. Can we expand that?
You split up at multiplication and division.
Can I put any red dots or red fraction bars?
Cannot be simplified.
This thing cannot be simplified. Why? Because you can't separate it. It can't be separated. You don't separate at addition or subtraction. And y'all know the common mistake people would write. Probably a 2 log base 3 of x plus 3 log base 3 of y minus 5 log base 3 of z. No, no, no. You cannot separate.
Log base b of m plus or minus, I'll say plus or minus n, cannot be separated. Or I'll say simplified.
I like separated.
I like separated too. If you have a plus or minus in the argument of your logarithm, you're going to be stuck with that plus or minus in the argument of your final answer. Wow. Number 6.
Okay, so number 6, let me see. It's going to take longer to, well, heck, there's not really any work to do before you just start typing in the answer. Number 6, log
base b x cubed y over z to the 7th. Okay. How many distinct factors do we have on top? 2, the x and the y. On bottom? 1. So how many minus signs are we going to have here? Just 1. How many logarithms are we going to have total? 3. Okay.
So what's the first thing he's going to type and I'm going to write? Well, I'm going to write it first. It would be, am I going to write the letter L or the number 3 first? 3 log base b of x.
Plus or minus? Plus, because you're still on top. Are we going to have a coefficient? No, because there's no exponent on the y. Plus or minus? Minus, I agree. Are we going to have a coefficient?
Yes.
What is it? 7.
Log 3.
Wait, is it log base 3 or log base b? Oh, okay. And now Tim will get to type all of that in.
Okay, let's make sure everyone has it written down. Oh. Okay, so here goes.
You've got to be careful typing this stuff in. If you forget to type one of those subscripts, it's going to count it wrong.
Notice here, we've done exponents before, and they call it superscript when you hover over the box, and I always said, well, why don't they just say exponents? Well, down here, you see the little blue box down low? There's the subscript box. So we're going to type 3. And notice I have to type logarithm, letter L-O. Look at what's about to happen when I type the G.
It spaces it and bolds it correctly.
I put the subscript. I click the subscript button. You see it has the little blue box down there where I type the B.
Don't put the X down there.
What do I need to do before I type the X? You got to get out of that subscript position. So that's an X. Plus log subscript b, and you got to type the b every time. Y.
Now, Tim, when you type it, type LOG capital in a moment.
Minus 7.
Look at what happens. Did it bold it or space it correctly? No.
Do not use capital letters.
You know what? Do this. Let me type in something. Let's go back.
Oh my goodness!
It didn't bold.
It didn't
what
bold.
did I do wrong? Oh my gosh!
No, it isn't the space.
I put a capital I instead of a lowercase l.
That's just a bad thing. A capital I looks like a lowercase letter L.
But
so type
never
L. There's O. There's the G. It bolded it.
And I'll put a subscript.
Subscript. Do y'all use the little keystrokes to get down there? A shift down arrow, just like a shift up arrow puts you in the exponent position. A shift down arrow, that seems quicker to me than going to the little hot button. Is that what I wanted to type? Okay, number 7. Oh, yes, that instructor tip again for number 7, warning you, type it with the lowercase letter L.
That tip will only show the first time you click on the problem. Let's see. Okay. Expand. Oh, at least they're using the word expand the logarithm. I like that terminology. Expand it. That makes you think, okay, you're taking 1 and making it into a lot, which is what you are.
They would go with the bottom and the top of those 3 1 shapes.
Oh, did y'all hear that?
Yeah.
Okay.
Mary Mae's really on ball today.
Hey, look, there's no subscript.
Hey, that's why common logarithms and natural logarithms, you're going to learn to love them because you don't have to type the subscript when you're typing in the answers, okay? What is the assumed subscript down here? I don't even see the little number. If you see LOG and no subscript, what's the assumed subscript? 10, correct.
The 10. Mm-hmm. That was one of those things I said at the beginning. I know we've been saying a lot.
Yeah.
Log x is log base 10. Okay. So. Oh yeah, you're ahead. The 8th root is a 1/8 exponent, and notice both of these are under that radical. The x and the z both have the 1/8 on them. Okay.
Any questions on the 8th root? Is the same thing as the 1/8 exponent. The x and z are both under the radical, so they both have the 1/8 exponent.
Like this one over here that I wrote, the 1/8 would only be on the x. On this one, it's clear that the z is not under the radical, but on number 7, the z's both of those are under that red 8th root. That's why they both have the exponents.
How many logarithms are we going to have in our final answer? 2. Okay, I agree.
So at this point, once you've written it with the 1/8, it's just a matter of writing down the answer. You got 1/8 log x plus or minus minus 1/8 log z. No.
No, you do not. As a matter of fact, if they don't... Yes, but if they don't show a subscript...
You don't put it.
You don't put it, because if you type in the 10, they'll count it wrong.
It as wrong.
Unless they corrected the programming, okay?
I haven't checked this year, but...
I'm going to have to check. I'm going to see.
Okay.
Okay. 1/8. Get out of that denominator before I type my LOG. Suppose I'd put in the 10. Okay, I'm going to try it just to see. No, for this first one, I'm not going to do it. I want to show you that.
You just type LOG, you don't type the base.
Okay, get out before I type my LOG. And what's the other letter? Z. Hold on, let me see something similar question. Okay, suppose that would be a 1/7. Let's suppose we put log subscript 10 a minus 1/7 log subscript 10 b. Technically, they should
take it right, but I think it's... Oh, it did. Okay. Well, perfect. Okay, so that's a change for the better.
I'll warn you, sometimes, just because they changed this one problem, they may not do it again, okay? I mean, they may not have changed it into other problems.
Hey, so I hate to, let me show the screen again.
Okay.
In algebra, you always do it one way, and then what do? You do it in reverse. You do it the other way. Could y'all go backwards? Looking at number 6, could y'all figure out how to go backwards? Sure you could.
Now we're expanding. In a few minutes, we're going to start doing something called condensing,
where we're going backwards.
When you expand, you take one thing and make it bigger. When we start condensing, we're going to have these multiple logarithms condense to get it smaller.
Well, we're not ready to condense yet. Let's do number 8. Oh, that instructor tip gets very annoying. What is that base? Is that a G? Log base G.
Okay, so that would be x to what power? Okay, a square root is the same thing as an x to 1/2. We'll have to rewrite that. Okay, let me switch over to Tony's paper.
So the one thing you have to do before you start using your expanding rule is to rewrite that square root symbol, that radical, with a 1/2 exponent. And then you're ready to start expanding.
How many distinct factors do we have on top?
Oh, on top. Just
On top 2, and on the bottom,
1.
so a total of 3. You were just jumping ahead.
And how many minus signs are we going to have?
1.
Well, that's the first thing I'm going to write down. There's only one correct answer. You got to start with that 1/2. 1/2 log base g of x. Then a
Plus or minus? Plus, because we're still on top.
3 log 1, 3g,
Plus or minus?
2 log
Minus the 2. Okay. Only logarithm that has a minus in front is the one that contains z, because z is the only factor in the denominator. Okay, I'm going to type it in now. 1/2, get out of that denominator, log subscript g, get out of the subscript before I type the x, plus 3 log subscript g, get out of there before I type the y, and then what do I type? A minus, because I'm ready to go down to the denominator, 2 log subscript g and a z. Any questions there?
Okay, number 9.
Oh, it's a natural logarithm. For what it's worth, you don't have to type any subscripts.
Yeah, I like the ln ones, also easier to type in, provided you're typing in a lowercase l and a lowercase n and not a capital I and a lowercase n. I remember years ago when my brother told me, don't show the steps when expanding logarithms. And I was like, that's crazy, Tim. Students don't want to, and he said, just trust me. And I was like, and if you look at the view and examples, click on view and example. How many steps am I going to have?
Well, there's
They go through
there's
just
5 parts.
Okay, they just go through showing all the steps every time.
There was one that had like 30 steps.
Oh, I know it. That's so funny.
And I just chose that.
But, okay, let's first of all deal with the square root. What are we going to do with that square root? Okay, that's an exponent of 1/2. Let me switch over to Tony's writing.
Notice that x squared plus 9, that's going to all stay together. You can't separate that. You don't separate
You cannot
logarithms.
separate over addition or subtraction. Your problem has an x squared plus 9 in an argument. Your final answer is going to have an x squared plus 9. If it has an x plus 9 down here, that x plus 9 will not be separated. It has to stay together as an x plus 9.
Now I'm going to put the little red dots and draw the line to indicate how it separates. It separates there.
So how many distinct factors do we have on top? Be careful. You have x and you have x squared plus 9. Okay? That x squared plus 9 is going to have to stay together. It can't be separated. How many distinct factors do we have on the bottom? 1, just the x plus 9.
That x plus 9 has to stay together. So once we've done that, then we write out, 2, let me move up, sorry. ln x, then it's a plus. Look at how I'm going to write that. I write the 1/2, then the ln x squared plus 9.
What's the next sign going to be? Minus, because we're ready to move down to the denominator. You bring down the 6. And you don't have a choice on the parentheses. You have to keep those things, if it's more than one term, something plus something or something minus something, you have to enclose them in parentheses when you're typing them. If you don't put the x plus 9 in parentheses, it's going to assume you're taking the natural log of x, and then whatever that is, you're adding 9 to it. If your argument has a plus or a minus, you want to enclose the plus or minus in parentheses. The expression in parentheses. Okay. I'm going to type in the answer now. So here goes. 2 L, notice I'm typing L in, and look what happened. As soon as I typed in that in, it bolded the notation, so you know you typed in the correct logarithm. X plus, I had 1/2, get out of the denominator before I type in. What happened? It didn't bold. I typed an I instead of an L. It's a lowercase L and a lowercase n. And then I have to put the parentheses. X squared, get out of that exponent before I type the plus 9 and close the parentheses. If your argument has plus or minus when you're expanding the logarithms, you have to enclose that argument in parentheses. Otherwise, without the parentheses, all you're taking the natural log of is that first thing there, x squared. And now plus or minus? Minus 6 ln. Maybe I'm lying to you. What do you think? If I put x plus 9, are they going to take that? Let's see. No. That's incorrect. They don't tell you check your parentheses. They just remind you of the product, quotient, and power rule. Without the parentheses, the only thing you're taking the natural log of is x. You want the entire x plus 9 to be in the argument, so you must enclose in parentheses. Any questions there? Number 10. Oh, it's more than no instructions here. Now it's time we're going to start going backwards. We've been expanding logarithms. Now they want us to write it as a single expression.
You know what? Let's do this one before. I'm going to make up an example.
Tony's going to make up an example.
Log base b of 24 minus log base b of 4. Imagine going backwards. We would say, okay, it's log base b. This is called condensing a logarithm.
The thing I always ask myself first is, do I need a fraction bar? And the answer is yes.
Because of that minus, it's going to be a fraction bar. 24 on top and 4 on the bottom. So,
24 divided
well, this one you could. 24 divided by 4 is 6. So yes. Log base b of 6. So you're not subtracting the 24 and the 4, are you? You're dividing them. Okay? So now let's do number 10, which unfortunately
doesn't work out as nicely
so
as the one you made.
Number 10, log base 4
of 22 minus log base 4 of 15.
The instructions will either say write it as a single logarithm or condense it, one or the other.
If you see the word condense, that means write as a single logarithm. So we write our log base 4, and the first question I always ask myself, do I need a fraction bar? And the answer is yes. What's on top? Okay. 22 over 15, can we reduce that fraction? No.
Maybe it would have been better if those had been variables, X and Y,
Yeah, I think
instead
it
of
would
22 and 15. That might have made the,
All right.
but we don't have control.
So log base 4 of 22 over 15. Come over here. I type my log, subscript 4, get out of there. I have a fraction bar. On top I have 22. On bottom I have 15. Any questions there?
This is going backwards from the expanding. In algebra, you always do it one way than the other. If I'd been thinking, I would have gone through and gotten rid of it. I mean, if we clicked on them beforehand. Okay. Here, write it as a single logarithm. Let's write this down. 9 log base 3 of z minus,
Your glasses keep hitting.
hitting, yeah. I'll try lifting it. Minus log base 3 of, is that a z minus 1?
Notice that z minus 1 is enclosed in parentheses. If you have a plus or minus in the argument of the original problem, you're going to have that same plus or minus in the argument of the final answer. That means you have a z minus 1 there, your final answer has to have a z minus 1. You cannot split up that z minus 1.
What's the common mistake? You just start thinking, I can distribute that log base 3 and get log base 3
If you
z
start doing
minus.
anything that you haven't seen us do in class, I'd bet large sums of money you're doing
No.
something wrong. There's not these properties of logarithms we haven't told you about, okay? So, let me go to the paper. Will I need a fraction bar in my final answer? Yes, because of what?
The minus.
That minus right here. This minus in the argument has no bearing. It's the sign in front of the logarithm. That minus says we're going to need a fraction bar. What are we going to have on top?
Z to the 9.
Z to the 9.
A common mistake, students will write 9z.
It
No,
will.
no. The exponent is the number in front of the letter L. Z to the 9th over
Parentheses.
z minus 1. Oh, that's a z to the 9th. It's sort of hard to read. So log base 3 of z to the 9th over z minus 1. I wonder how many steps they do that in on view an example.
Log subscript 3, get out. Here's my fraction bar. I have a z to the 9th on top, and on the bottom I will have a z minus 1. Now, since this is the only thing down here in the denominator, if you don't put those parentheses around the z minus 1, you'd be okay.
But if in doubt, if it's in parentheses to start with, it's never wrong to leave them in parentheses.
Oh, what did I
we
do?
wrong? Log base 3.
Z to the 9th. Surely not.
In the past, they let us leave them in parentheses. I don't see anything.
Z to the 9th. Now, I'm just going to have to
Try removing
call
those
what's her
parentheses.
face. Let's see.
Can't be. I mean, they can't not take it with the parentheses.
No. Are you sure you copied the problem down right?
Oh.
9 log base 3 of z minus log base 3 of z minus 1.
Copy yourself.
So, z to the 9th, that's right. And z, no, that's right. Well, I'm gonna do this. Log subscript 3. Maybe I had some little hidden symbol there. Z to the 9th on top. Z minus 1 on the bottom. This is my final check. Log base 3.
I wonder, maybe you hit a space key?
But
the parentheses around it in the past, hit similar question to make sure.
Yeah. Okay, so that is a log base 2. I do a z to the 8th, z to the 8th on top, and a z plus 1 on the bottom. Okay. Oh, what happened? Well, I've lost my, there it is. Check answer.
I think maybe you'd hit a space or something. Maybe.
Yes, I
told you
did.
not to do that.
I know. It was an accident then.
That's number 12.
Oh,
That's number 12. Oh, I'm so
oh
tired
yeah,
of
those
those
instructor tips.
Is there going to be a lot of work on this? Or just basically you're going to write down the answer, write the problem down and write down the answer?
2x plus 7 on top of x in the bottom.
Okay,
Okay,
did y'all
we
hear
know
that?
we're going to have we know we need a fraction in the argument of the final answer because of that minus.
Mm-hmm.
And so, let me switch over to where you are there.
So that minus, we have a fraction. The 2x plus 7. Theoretically, you don't have to have it in parentheses since there's nothing else up on top and the x doesn't. But if you include them as a general rule of thumb, if they have them in parentheses, it's not a bad idea to leave them in
You
parentheses.
see, if it's just one single term as the argument, I wouldn't bother with the parentheses. But if there's a plus or a minus, I bother with the parentheses. So let's see.
But
I'm going to put in parentheses on both of them just to see, because that first one that that previous one just seems so strange. Log 2x plus 7 on top and x on the bottom. Is that what I wanted to type?
Anything
No,
else?
don't click anything else.
So what kind of this?
And if you didn't type the parentheses, watch this. I'll say similar question. If you type it without the parentheses, it should still, since there's nothing else up on top, just the 2x plus 5, nothing else down there, it should count it correct. And sure enough, it does.
Oh, wow, that was a long instructor tip. Oh, because this is a ln. 1/2 ln x plus ln y. I just say ln rather than reading that as natural logarithm.
Okay. Write the ln, Tony.
Okay, I'm going to write
And
it
then I
down.
have a question. Do we need a fraction bar here? No, because there's no minuses. The logarithms are being added, so we're not going to divide. What are we going to do to x and y? Multiply, that's right. They're not being divided, they're being multiplied. So you have x times y, but what about that, where does that 1/2 go?
Yeah, okay. So the 1/2 is an exponent. And you can rewrite that 1/2 exponent as a square root. But make sure if you do that,
Do not put the y under
Under
the
it.
square root. And my
Pearson
math,
will take it. Oh.
yes, Pearson will take either one of those answers.
Mm-hmm.
Either one of those. And notice something. We don't need to put a parentheses around the x to the 1/2 y. They're not being added. When you have addition or subtraction inside the argument, that's when you want to put parentheses around it. But here, that's an x to the 1/2 times a y. You don't need parentheses. Which one do you want me to type? The one with the x to the 1/2 or the square root of x? Pearson will take both of them. The first one? Okay.
I think that's probably where most people would stop.
I would think so. ln x to the 1/2
Oh, I don't think that looks very attractive.
It doesn't, but and you have to get out of that exponent position before you type the y.
I think I mentioned, I like those fractional exponents written horizontally, 1/ rather than vertically like that.
But email Pearson and
Yeah.
tell them.
Yeah, they're going to listen real closely to anything I say.
Any
Number
questions there? Okay.
Oh, more instructions. Oh, wow.
Okay, we're still condensing. We have 2 logarithms. We want to write it as 1 logarithm. You know, y'all can just call it out to me. I bet you we don't even have to switch over to Tony's page.
Yeah, I think you're right, Tim.
Okay, so I'll type that log B, log subscript B. And remember, I'm using a shift down arrow for that subscript, or you can use the little hot button. That'll get you down there. Then you got to get out of that thing.
Is there a fraction?
Is there a fraction bar here where I'm about to type? No, so what do I type? X to the 7th. And then, I couldn't hear you? No, I think you're going backwards. I think it's Z. Maybe you should have written it down.
I am.
Come on.
That's what I meant. I said it.
Oh,
okay.
Oh, okay.
Notice it's x to the 7th and then z squared. Do not.
Move that plus over there.
Sometimes students will all of a sudden put a plus right there. No. Now, if you thought it looked better by putting the z x to the 7th, the z squared in parentheses, it'll take that. Okay?
And it does look better.
It does look better with the parentheses.
You do not enter. The only way you can have a plus or minus in the argument of your final answer is if you start off with a plus or minus in the argument of the original problem. The argument is the step that follows the LOG or LN notation. You had a plus in that argument, you had to have a plus in the final answer. You had a minus in that argument, you had to have a minus in the final answer. You cannot pick up a plus here because there were no pluses in the argument of the original problem. So,
Remember the time the student said, no, you're just writing the problem and writing the answer. Yeah. And my response to that is, if you want to see steps, click View an Example. They'll show you all the steps you want to see. Trust me.
and some you don't want to see.
Okay. 9 ln x plus 3 minus 5 ln x.
Hey, is this going to be like number 14 where there's no fraction? No, it's a fraction bar because of that minus right there.
So I'm going to type. All right. ln fraction bar. Did y'all hear that? X plus 3 to the 9th.
And you've got to keep the parentheses around that x plus 3, okay, over x to the 5th. I agree.
Oh, wow. 20 short years, we'll be through. There's only 20 problems here.
24.
Oh.
ln, then I have a fraction bar, x plus 3. Did I
There's
yell
4
that?
videos and stuff.
Oh,
There's only
well,
20 problems.
Oh, okay. Okay. And then x to the 5th. Oh, is that what I wanted to type? Any questions there?
Oh, wow. This is a good one.
6 ln x
It's either going to be real
plus
easy
4 ln y minus 5 ln z.
so I'm going to say equals. All right, ln, will there be a fraction bar?
Yes.
Yes, because of this minus, there's a fraction bar. And what? Ln, first, ln x to the sixth. No. The 4 is the exponent on the y. Okay? The x plus 4 isn't in parentheses. The only thing, the argument for this ln is x. So it's x to the 6th and y to the 4th. Do not put a plus up on top.
I remember the little multiple choice test questions where they'd have x to the 6th plus y to the 4th on top. Half the class would choose that wrong, and I'd have to go in and tell them.
They've slowly gotten rid of
Yeah,
all
they've
the
gotten rid of
multiple
all those
choice.
multiple choice, and I'm glad.
And on the bottom, what am I going to put? Z to the 5th?
You cannot put a plus there between the x to the 6th and y to the 4th because you didn't have a plus in the argument of the original problem. The only way you can have a plus in the argument of the original problem is if you have a plus in the argument. The only way you can have a plus in the argument of the final answer is if you start off with a plus in the original problem. Any questions there?
That looks
And
like a Z to
common
the 51
mistake is
power.
typing a plus right there.
Right here. Mm-hmm.
Okay, so it is ln, I'm going to need a fraction bar, x to the 6th, get out of the exponent, y to the 4th, all over z to the 5th.
Any questions on this? Before we go on, number 16 is number 17 is the hardest problem we've done so far. Not
Dig
great.
out your calculator.
Okay, just wants to see, do you know how to find the LOG calculator? LOG on your calculator. On this one?
Mine, I figured out how to do it. I think on my phone.
Oh, okay, so let's see. You think-
LOG.
So there's our LOG. Hit
And
LOG.
click LOG, and notice it opened up a parenthesis. When I clicked the common log button, it opened up a parenthesis. So we have to put in the 40. If your calculator opens parentheses, you need to close it. We're going to be punching in very messy stuff the next time. And if your calculator's opening a parenthesis and you don't close it, then you're going to get dramatically wrong answers, okay? You might even get syntax errors. So, okay, you see, the common logarithm is not that common anymore, okay? And so it's getting to where you're seeing the little subscript types there. I hit enter.
And we're told to round it to 4 decimal places.
10 to what power gives us 40? 10 to the 1.602.
If we're rounding to 4 decimal places.
Is it going to be 6020 or 6021? 21. Remember, the digit that's following it is a 5 or more, so you boost up. So 6021. 1.6021.
Oh, well, you never even showed all my work thing. What I was
Oh, well,
showing.
there's your work. Okay, there.
I didn't do anything other than just write down the problem and write the answer.
I have a quick question.
Okay.
Yes.
So, like, I don't have the fancy calculator. I just use my phone. Will I have to go out and buy one or borrow when I'm taking the test for that one problem?
No, well, you need a calculator, especially for what we're doing next time. You need a calculator that you're very familiar with, because we're going to be punching in some messy stuff. And if you're using your phone calculator, okay, you can hold it up when you're taking the test, hold it. I'm using my phone calculator, okay? Just hold it.
But you cannot be doing
You can't be doing
this with photomath.
You can't be taking pictures.
Because that little software system, Pearson's going to be sending us 1,000,001 flags on you. That's what they do. They have it recorded, and then they're, okay, here are all the flags.
They even show us exact second where the test is going when you're doing it, okay? So they don't make us just watch through it. They tell us where to look.
I'm familiar with that. My husband didn't know I was taking a test.
Oh, okay. So on our calculator, we have a log base 10 key.
I had a student. The child came in there and she was like, oh, she had to stop and change the diaper. Oh, that was funny.
But on our calculators, pull up the calculator. There's only 2 logarithm keys on this calculator. Oh, there. The LOG and LN. There's 2 logarithm keys. Log base 10 and log base 2.718281828. Now, the natural question to ask is, how would I enter a log base 5? On my calculator, there's no log base 5 key.
It's either LOG or LN on most calculators. There are a few obscure Casio models that have a log base B key. It's amazing what you can get with a $20 Casio calculator, but anyway, there's a way of converting. You can convert a log base 5 to either a common log or natural log and evaluate it on your calculator. It's called the change of base formula. Log base B of x. You can rewrite it.
If you want to use LN,
it's ln x over ln b.
Or if you want to use LOG, it'll work as long as you don't mix them. Log x over log b. I think I generally use LN for change of base.
I do.
Okay.
Because if it were a different a logarithmic function, then we're going to have to differentiate. It's easier to differentiate natural logs. So,
but now, what is that problem number 18? It was log base 5 of 60. There's no log base 5 key on our calculator.
Our calculator only has LOG or LN.
Okay.
The hip, more current logarithm is LN, so that's what I think I'll use.
And it goes like this. You're going to put LN on top and on bottom. And you've got to remember which number goes on top and which one on bottom. The number that's written lower, that subscript, is the one that goes on the bottom. 60 would be on top, the 5 on the bottom. You're hitting LN twice.
LN, notice what it just did. It opened a parenthesis. I have to type in the 60 and close the parenthesis. Divided by, I press LN. If it opens a parenthesis, you have to type that argument 5, close the parenthesis, and I'm warning you the next time the messy stuff we're going to be typing, if you're not closing the parentheses, your answers will be wrong.
So is this, how do they say it around this? 4 decimal places?
Yes.
Let's see.
So 2.5.
Wait.
Oh, 5,
4.
4.
Is it going to stay 39 or is it going to get boosted up to 40?
40.
Okay, so 5440.
And once you see that that's right, I want you to punch
5440. You want me
You
to
have
do
to do
what?
the 0?
Oh, I think they won't make you do the 0, okay, since it is a 0. But go back to the calculator and re-enter that without closing those parentheses.
ln 60 divided by ln 5. Are we going to get the same thing?
No. 3, you've got to close those parentheses. If you don't, you're going to get the wrong answer. What about number 19?
Okay. Log base 5 of 0.15.
Log base 5, another base 5, huh?
We could use it for log base 7, log base
Yeah.
3, anything. Any positive base other than 1.
So that change of base, there's not a base 5 on our calculator. So ln,
What number is he going to write right here?
which one goes on top and which one goes on bottom?
0.15 goes on top.
And then 5.
The number that's written lower is the one that goes on the in the denominator. I'll put those parentheses because my calculator opens those parentheses.
ln 0.15, right parenthesis, divided by ln 5, close the parentheses. And how do they want us to round? 4 decimal places again. 1.7. Is it going to stay 8.7 or is it going to go up to 8.8?
8.7.
8.7. That's a 4, so you leave the 7 as is.
Oh, I can get better. Oh, yeah.
Okay, so a negative 1.1787. So if you want to evaluate a logarithm that
Isn't log base 10 or
log base e, then you can evaluate it using the change of base formula. The change of base formula changes any logarithm to either log or ln. And there was one other thing I wanted to do. I wanted to point out that you'd get the same answer if you use log. Log 0.15, close parenthesis, divided by log 5, close parenthesis. We better get the same thing.
but don't mix it. Don't use log on one and ln on the
Other, because then you'll
get it wrong.
Yes.
It's
Any
gotta be
questions?
consistent. Oh wow. Okay, are we finally ready for this last problem? I got to state a new rule.
Honey has to state a new rule.
What we can say is that e, the exponential function e, and ln are inverses, so they cancel each other out when there's nothing between them. E raised to the ln x is just x. What I'm saying is e and ln cancel each other out.
The natural exponential and the natural logarithm are inverse functions. When they're performed consecutively in either order, they cancel each other out.
If it's written like this, e and ln, they cancel out. If it's written with the ln first, they cancel out.
And that's a direct result of, go back to that one of those first rules that he stated.
Oh, yeah. This one right here.
Yeah.
ln is log base e.
So ln
Log
e to
base
the x,
e to the x is just x.
e
E.
to the ln x equals x. So that new statement, new rule he gave us, it's just a restatement. It's stating this in terms of e
And ln.
and ln.
And now number 20 is the last problem, so y'all know what that means. It's got to be the hardest. Not really. We're given a function. F of x equals ln x. And part A says to find f of Oh, yeah, you're ahead of me. E to the negative 3. With function notation, whatever's in the parentheses goes in place of the x. It's been a while since we've done any of this plugging in. So in place of that x, I'm going to put e to the negative 3.
What's going to cancel?
L
L
and E.
and E, they're consecutive inverse functions. They're canceling, leaving us with the final answer of negative 3.
Mm-hmm.
So part A,
So E and LN cancel each other out when they're side by side.
what about f of e to the ln 4?
Oops, this is B. F of E
To the ln 4.
to the ln 4. Okay.
So we come up here. We're going to replace that x with
All of that. So I'm replacing the black X with the blue E to the ln 4. And here there's actually a couple of ways you can cancel.
some students go into a cancellation frenzy and just mark out everything except the 4. But remember, it is a one-to-one correspondence. You can cancel one e to the ln, or you can cancel one ln e, but I think we're still going to be left with something other than 4. What is it? Not e. We can cancel that ln e there, in which case then we're left with just ln 4.
Yeah, you could
Or
go-
we could cancel the e to the ln. And we're still left with what? ln 4.
Okay, do y'all see how you can cancel? You can cancel the blue E and the blue ln, or you can cancel the black ln and the blue E. I'm going to do that.
I think it looks better like that. And
Okay.
that leaves us with
The blue ln 4. But if you canceled the E and the blue ln, you would have had the black ln and a blue 4, still ln 4.
any questions there?
See how I canceled?
Okay. ln 4. E to the 5 ln 4. F of e to the 5 ln 4. That says go to your function f and replace that variable here with,
So we have the black ln.
and then we're going to replace that x with the blue e to the 5 ln 4.
Here, there's only one way to cancel.
What can we cancel? Okay. You say, well, E and LN, they're not consecutive.
Yeah,
There's
you can't-
something between the blue E and the blue LN. What's there? That 5. So they're not consecutive functions.
Uh-huh.
But we do have a pair of consecutive inverse functions right here. The ln E we can mark out, and that leaves us with 5 ln 4.
See, you can only cancel them if they're side by side, the E and LN. Over here, the E and LN on the part B, they were side by side there and there. So you had two choices. Either way would get the right answer. Here on C, the only thing you can cancel is the black LN and the blue E. You can't cancel the blue E and the blue LN because there's something between this blue E and LN, the 5. So 5 ln 4 is our answer there.
5 ln 4.
Oh, you're sighing or tired, Tim? Are you yawning?
No, I
Oh,
was
it sounded like you were.
Oh, was I? I was just breathing real deep. Okay.
Yeah, you look at that. Tim still, we've done all the problems, but he only has an 83.33. Do y'all know why that is? He
The
didn't click
videos.
on all the videos. So,
Hold on.
Shame on you.
Yeah. Oh, well, that's okay.
I'm going to come over and click it right now.
That's
But-
going to take longer.
What did I just do?
What the heck is that?
That's a new print screen.
Okay. Any questions?
Who the heck are these? Oh, that's the Pearson videos.
Why are they saying
There. Any questions?
questions? Number 2. What did we do? Why didn't we get an answer for number 2?
We did number 2. Did you not type it in? Oh, yeah, we did number 2.
What was
It was-
2/3?
Yeah, 2/3. I guess you just didn't type in the answer. Okay.
Yeah,
Okay, well, if you have any questions, we'll try to answer them. Otherwise, we'll see y'all on Wednesday when we'll do more of this logarithm and exponential stuff. Tim, why don't you stop recording?
I'm going to, yeah.